Hey everyone, let's check out some inverse trig functions. Recall that the graph of sine was an oscillation of hills and valleys, and this was the graph of sine x. If we limit ourselves to two angles which capture all of the y values from -1 to +1, one of those intervals would be from -π/2 to +π/2. Between these two angles, the graph of sine is covered from bottom to top. The complete range is covered. Now, when you invert, if you were to reflect this across the x-axis and then turn 90 degrees counterclockwise, you would have this piece of the graph that's highlighted above in red. The domain for sine inverse, and before I go too far, let's remember from college algebra, if a graph passes a vertical line test, it's a function. If it also passes horizontal line test, it's a one-to-one function. That's important to remember. So once inverted, you still have a function. The domain of the highlighted part after it's inverted is the range of the original. So domain is -1 to 1 inclusive. The range is -π/2 to +π/2 inclusive. Now, for me, it's easier to work trig inverse problems associating it with the unit circle. You don't absolutely have to do it that way, but for me, it's the easiest. So what I do is, for sine inverse in particular, I mark off an arc from +90 down to -90, π/2 to -π/2, and I come out here to 1. Sine inverse of 1/2, basically what you're looking for is the angle that you take the sine of to get 1/2. In this arc, the angle that has a sine value of 1/2, the angle that has a sine value of 1/2 is π/6. I kept these numerically coded. That's that first angle here, first inverse problem here. Sine of π/6 is equal to 1/2. Number 2, suppose we're asked to find sine inverse of -1. What angle has a y-coordinate or sine value of -1? Well, that would be at the bottom of the unit circle. That's -π/2. Be very careful not to answer 3π/2, even though it's the right location. 3π/2 is not in this interval. So we have to go with -π/2. Sine of -π/2 is in fact -1, so that's the correct angle. Occasionally, you'll be asked to find a sine inverse of a number that doesn't fall in the proper domain. 3 is not in the domain of sine inverse, so you just wouldn't work it. It's undefined because 3 is not in the domain for sine inverse. Cosine x, let's recall it oscillates very much like sine, up and down forever. In order to capture all the y values from -1 to +1, I closed off the interval 0 to pi. Same case, if you invert this by reflecting it across the x-axis and turning it 90 degrees counterclockwise, you will get this portion of the graph. That's the inverted part from the red up here. This is the graph of cosine inverse of x. The range of cosine becomes the domain of cosine inverse. And because it took from 0 to pi to cover all the values of the trig function, that's going to be our range. It's the domain up here, but it's the range in the inverse. Compared to the unit circle, from 0 to pi, that's the top two quadrants. So with sine inverse, you look at the right two quadrants, but with cosine inverse, you look at the top two. Number 1, cosine inverse square root of 2 over 2. What this is asking is what angle has an x coordinate. Remember, cosine is tied to the x's. What angle has an x coordinate of square root of 2 over 2? Find that on your unit circle, and you'll see that the angle is pi over 4. Cosine of pi over 4 is square root of 2 over 2. Another example, cosine inverse of 0. What angle in these two quadrants have an x value of 0? Well, that's up at the top. Cosine of pi over 2 is 0, so the appropriate angle is pi over 2. A third example would be cosine inverse of -1. What angle has an x coordinate of -1? That's pi. Cosine of pi is -1, so that's the appropriate angle. So you got to be careful. You got to stay in the correct two quadrants. Find the x value for cosine inverse, the y value for sine inverse, and just give the angle where this value is true. Cosine inverse of 3 is undefined because 3 is not in the domain. Let's recall one cycle of tangent. We had vertical asymptotes at the odd multiples of pi over 2. This just happens to be the middle streak of the tangent graph. This is far enough to capture the range. Again, flip this over the x-axis and then turn it 90 degrees counterclockwise, and you will get this graph. This is the graph of tangent inverse. Passes vertical and horizontal line test. Vertical, horizontal line test. So that means when you invert the graph, it's also a function. Domain, all real numbers for angles. The range is the values of y between the asymptotes. Now you don't include them, so there's parentheses here. Those are horizontal asymptotes. Vertical asymptotes in a function, as long as it's a one-to-one function, become the horizontal asymptotes in the inverse. Compared to the unit circle, negative pi over 2 to positive pi over 2, I left these open on purpose because you don't include those two angles. Why is that? Tangent's undefined at those two asymptotes. The way you read this, tan inverse of 1 is what angle in these two quadrants has a slope, because tangent is y over x, which is rise over run, of 1. Well, the angle that has a slope of positive 1 occurs here. That's pi over 4. Tangent of pi over 4 is equal to 1, and so that's how you work that one. Another example would be tan inverse of negative square root of 3. The way you translate that, what angle in these two quadrants has a slope of negative square root of 3? That angle. Now, from the unit circle, you can identify that as 5 pi over 3, but be careful not to use that angle because it's not in the range for your inverse. What is in the range is if you were to work your way negatively from 0 to here, that would be a negative pi over 3. Tangent of negative pi over 3 is equal to negative square root of 3, so all is well. Or maybe all is good. I think you'd have to use a linking verb. Anyway, luckily it's math. What angle has a slope of 0 in here? Well, slope of 0 just automatically says we need a flat angle. So that's 0 radians. Tangent of 0 is 0. And so that one has been finished. More examples and how to read inverses. And I did this a lot on the previous slide. You can't really overkill it because inverses are kind of tricky anyway. So suppose your problem is this: sine inverse of square root of 2 over 2. We already did one like that. But the way you read it is start in the middle. What angle between these two, or in those two quadrants, has the y-coordinate, sine is y-coordinate, of square root of 2 over 2? And that would be the right angle, correct angle, pi over 4. For cosine inverse, what angle between 0 and pi? It's a different set of quadrants to look in. Cosine is tied to x coordinates of negative square root of 3 over 2. On your unit circle, find the x coordinate of negative square root of 3 over 2. You'll find it at 150 degrees, or 5 pi over 6 radians. And then for tangent inverse, you're back to the right two quadrants. What angle between negative and positive pi over 2 has the slope of square root of 3 over 3? That's at 30 degrees, or pi over 6 radians. Evaluating compositions, you'll see a few of these show up in your homework lesson. Find the exact value of each expression. Now there's two ways that these can be written, and that you will probably see both. Arc cosine is another way to write cosine inverse. Tangent of arc cosine of 2/3. Now, with inverse, you're looking for an angle. So what I'm going to do is I'm going to substitute the inside part with a single letter, call it U. So I'm going to replace this with the single letter U. If we let U be cosine inverse of 2/3, and then we take the cosine of both sides, or uninvert it, cosine of U is equal to 2/3. Draw a right triangle, mark an angle U. Cosine is adjacent over hypotenuse, so that's where the 2 and the 3 go from 2/3. 9 minus 4 is 5. Square root gives us this third leg, third side. Now, because we're looking at tangent of U, from angle U, tangent is opposite over adjacent. That's square root of 5 over 2. And so that's how you approach these compositions. You take the inverse part in the inside of the parentheses, give it a letter. That's going to represent an angle. Once you uninvert, that's really not even a word, but it kind of gives you a visual of what's happening. Use your identities, cosine, or actually definitions. Cosine is adjacent over hypotenuse, to label 2 of your 3 sides. Then use Pythagorean theorem to find your third side. And then, whatever your outer trig function is, from that angle, use its definition. Let's do another one. Cosine of arcsine negative 3/5, which can also be written as cosine of sine inverse negative 3/5. Take the internal part, assign it a variable. We're going to let U be the sine inverse of negative 3/5. Bring your inverse over. That's sine of U equals negative 3/5. Draw a right triangle, mark off an angle U. Sine is opposite over hypotenuse. Now because that's negative and sine inverse, I need to draw a triangle where U appears to be in quad 4. Opposite over hypotenuse, negative 3/5. Using Pythagorean theorem, 25 minus 9, that's 16, square root is 4. Cosine, which is the outer function of that angle, cosine of this angle is 4/5. And then if you go as far as calculus 2 in your math sequence, you're going to see some of these where the variable is left in the problem where it's not purely numerical. For example, sine of cosine inverse 2x. The approach is still the same. Let this be an angle. I just am in the habit of calling it u. You can call it theta if you prefer theta, but the internal part becomes an angle because it's an inverse. That means it's an angle. Cosine inverse of 2x, that tells us that cosine of u is 2x. Think of this, 2x you can also write as 2x over 1. Cosine is adjacent over hypotenuse, so 2x over 1 comes in pretty handy. 1 squared minus 2x squared, that's 1 minus 4x squared, square rooted gives you the length of this side. It's Pythagorean theorem, but it's kind of difficult to put it all together. Now let's go back to, once you've got your diagram finished and all three sides labeled, then go back to your outer function. Sine of this angle, which is sine of u, is opposite over hypotenuse. Square root of 1 minus 4x squared all over 1. If you divide by 1, you don't change anything. I hope this video helps out. Please reach out by email or phone, or come by the office if you have any trouble, or ask in class, and I'll do my best to help you out.